Let's just have a short introduction on fractions here real quick. A fraction is a part of a number. It can be a whole number and a part of a number, but we're basically following those gaps, our rational fractions, or our rational numbers that are in between whole numbers, integers, natural numbers. All right. So on a fraction, there's some things you got to know. For example, I've got the pen on. There should be a numerator over a denominator. Now, as we talked about that previous, or as you should know from previous mathematical lessons, okay, because we name it a numerator, it's a grouping of things. So if it's just a single number, then we've got everything together. If there's more than one operator that sits up here, we're going to have to condense, evaluate, and then we can divide by our denominator. But this is just another way of saying division. All right. On a proper fraction, we have two different kinds of fractions. On a proper fraction, it will always be less than 1. Okay. So you will always get things like 2 over 3. So we have 2 blue markers out of 3 markers. Okay. Or maybe I got 2 hits. If I'm a baseball, softball player, 2 hits out of 3 plate appearances. Okay, this is always less than 1. So if you did this, this would be a decimal number. It'd be 0 decimal something, all right, or less than 1. An improper fraction would be quite the opposite. And of course, this now is harder to say as the ratio that I explained earlier. I can't have 3 blue markers to 2 markers, okay, or 2 total markers. This now no longer is a total kind of a thing, okay. But if I look at this, or I can't have 3 hits out of 2 at-bats. Those just don't make any, it doesn't make any sense. So it's not necessarily a total here if we relate it that way. However, on our fraction, this number here, our improper, let me get back over here, should be greater than 1, which could also be written as a mixed number because this has a different value. And sometimes when we get to a little larger numbers in real world, we don't want to hear we got 3 halves of something. We want to know that we have 1 and 1/2. Notice the denominator is still the same. 2 goes into 3 one whole time with the remainder of 1 more. Okay, this is a mixed, I have no idea why I went that way, mixed number. Okay, so just an overview there. Now, how we're actually going to deal with those guys. Okay, we have some operators that we can do. All right, and multiply. So let's just take a number here. Let's go 2/3. Let's take it times 4. Let's do something here. I don't know, 9ths. Okay. Now, we have rules for when we multiply, and our rules for when we multiply say this. And I'm going to paraphrase this because I think it's easier to remember. Tops times tops, bottoms times bottoms, and then it's a fraction, which means we always have to look to reduce. Okay, so if we come back down here, tops times tops, so 2 times 4 is 8. 3 times 9 is, and it goes to the bottom, which is 27. And then this guy just happens to be reduced. So I've looked to do that, it just doesn't do that. Now, yes, there are times, and if you understand this up here, our rules completely, there are some times that we can get away with this because this is multiplication, tops times tops, bottoms times bottoms. Reducing is actually division. Okay, and we can divide what comes out of the top comes out of the bottom. All right, so let's take a look at another look at this guy. Let's go, I don't know, 1/4, and then let's take it times, let's say, 10/11. All right, so if we look at this way, we can actually, because these are the same operators, multiplication and reduction is division, I can actually look to reduce here. Yes, I can go 1 times 10 is 10 and 4 times 11 is 44. So I have 10 over 44 and that reduces. Well, how does it reduce? Well, it actually could have reduced. Change pens here. Right here. Because anything I can do to the top, I do the bottom. And so if I can take 4 out of there, which I can't, but I can at least take the 2 out, right? So I'm going to take a 2 out and get 2 over here. If I take my 2 out through division, I get 5. And now everything seems to be reduced here. So I did this step first. And I get 5 over 22, which if you recall, that 10 over 44 number, you could have divided both top and bottom by 2 and gotten 5. 20 seconds. When we divide, okay, so let's just take a number and let's go, I don't know, again, 2/3. Let's divide it by 1/4. All right, our rules here with division is actually what, and I got this from a student of mine a long time ago, copy dot flip. And the easiest thing about division, division is actually probably the easiest thing. Copy dot flip. I must have had a couple boxes or something open up and I don't know why. But copy dot flip. This is the easiest thing to do in fractions because we have 3 things there. Let me do that again, right? I have copy, I have a dot, and I have a flip. I have 1, 2, 3 things here. So when I do this, it becomes very simple. I copy, which is 2/3. I dot, which is another way of saying multiply, and then this becomes a reciprocal. Okay, and then I can go back to this guy, right? And I can say, oh, tops times tops, bottoms times bottoms, and reduce. Nothing reduces within, so it's just tops times tops, which is 8 over 3. Okay. Now you got to be kind of careful because sometimes these numbers aren't just proper fractions. So if I do, I don't know, let's go 1 3/4 divided by 2 1/2. When I copy dot flip this thing, mixed numbers will always work better as improper fractions on both multiplication and division. So when I copy this guy, I go 4 times 1 is 7, plus 3 is 10, dot, flip, so this numerator, 4 and 1 is 5, and then I can reduce within, right? So I can get a 2 out of both top and bottom there, which gives me 1 and 2. I can get a 5 out of both top and bottom there. So this becomes 2. That becomes 1. And if I wanted to, I could do it one more time and say 2 over 2 is 1 over 1, right? And everything there is now reduced. And anything divided by itself is 1. Or 1 times 1 is 1 on the numerator. 1 times 1 is 1 on the denominator. Anything divided by itself is 1. The next thing we have is add and subtract. And add and subtract require we have what's called a common denominator. Okay, only on add, addition, and subtraction. Now it has the least amount of rules, but there's a lot of things that go into it. Okay, so if I add, let's say 2/3 plus, I don't know, let's go 1/9. I don't have a common denominator. So I've got to rewrite this thing with the same common denominator. And that common denominator between 3 and 9, that's all I'm looking for, is the least common denominator, is actually 9. At that point in time, I can simply just apply my denominator. Now, there's another step in here, because this 3 I had to take times 2 to get this 9. What I do to the bottom, I do to the top. And now this guy here becomes 4. And 4/9 is just an equivalent fraction of 2/3. They are the same value. Okay. And now we have 1/9. We never changed it to get this 9 on the bottom. And we just do the tops, right? So we're just going to look at, the tops. And when we do that, we get 5 all over that common denominator of 9. Now, yeah, we can do that again with our mixed numbers, right? We can say, and let's do this way this time. Let's go 12 minus 3 3/4. Okay, I strongly urge you, okay, there's a couple of different ways we can do this, but I strongly urge you to make sure that you have what you understand as a common denominator. So here my common denominator is 4 times 3 is 12 plus 3 is 15. This guy still has to have a common denominator of 4, which 4 times is 48. I still have that common denominator of 4, so I apply it. 48 minus 15 is 33. And then that's all I require in class. If you want to do something more, yeah, you can also say, all right, fine, 4. 4 goes into 33 how many times without going over? That would be 8. Because 4 times 8 is 32. Subtract that from 33 and I get a remainder of 1. All right. And now you could have gotten that from right up here. I'm not saying you couldn't. If I take 3/4 from 12, I get 11 and 1/4. Take 3 from 11, you get 8. Okay, it can work that way, but this is kind of the way I've explained it. If you have any questions on anything else, go ahead and reference this. You can also reference some other videos online. Check your book. All right. Good luck.